Now we compare the two models. Okay, the first model, remember, is x plus 2.5 quantity squared. If we evaluate this at x equals 1, 2, 3, and 4, we get these values, as you can easily verify. And these values stay pretty close to the values of the function. The residuals that we get by seeing how this value compares with this value is below the value of the function, so the residual we say is negative 0.35 because 11.9 is 3.5 less than 12.25. Somehow I got my signs wrong here. This residual should be negative 2.95. I think I got tied up my arithmetic and lost track of which one was bigger. This one should be negative 2.05 and this one should be negative 1.45. All the residuals are negative so that this function overestimates a little bit. But remember that I did this estimate on a very rough graph and by an eyeball estimate, and you'd really want to, for example, put the linearized data into derive and get the regression model, the linear fit model, and find out what that is, and that's what you'd be squaring here. And it might actually come out a little bit closer than what I've got here. However, we see that it does come out pretty close. Now, let's try the 7.9 times 1.51 to the x model. Okay, 11.92, 11.9, 18.01, 18.3, 27.20, 28.2, 41.07, 41.8. These are much closer to the observed y values than these are. Even though this is a pretty good model, this is an even better model. We see the residuals here are all less than 1 except this, which is equal to 1, and a couple of them are a lot less than 1. So that this seems to be a better model, but you'd have to go to derive, for example, and put in your linearized data, find out what your fit is, and then solve the resulting equation to get your model before you could really be sure which one was the better model.